Okay, so there are two quadrilaterals that are not parallelograms, and that's it. And so we need to talk about those and their special properties. We'll finish up your flow chart, essentially. But also we're going to look at how to find the length of the mid-segment of a trapezoid. And so we've talked about midpoint and mid-segment before, looking at how that works in a trapezoid itself. It's really kind of a cool relationship. But a trapezoid specifically is a quadrilateral with exactly one pair of parallel sides. It can't have more than one because then it would be a parallelogram. So only one pair of parallel sides. So you can see these drawn a couple different ways, but here's one way. Here's one way. And we have something like that even. So again, the only criteria is that you have something opposite something else that is parallel to it. Okay. The bases of the trapezoids are the parallel sides. So regardless of which direction it's facing, the two sides that are parallel are considered the bases. So it doesn't have to sit on the base. Keep that in mind, same as with our triangles before. So if we were to, for example, label this one up here, A, B, C, D, the bases would be AD and BC. Okay. The legs of your trapezoid are the non-parallel sides. So again, looking at the example above, it would be AB and CD. The base angles of the trapezoids are the angles made by a leg and or the two pairs of angles that touch a base. So you have A and D. Those would each be base angles. Also, angle B and angle C would be base angles on the other base. Okay. So we'll talk about special relationships between the base angles. Keep in mind, like A and D are along the same base, so they'll go together. B and C will also go together, okay, when we get to that. All right, so graph the vertices of the quadrilateral. Decide whether it's a trapezoid or not. And so even if I don't give you a graph, if you get coordinates for any of these lessons, go ahead and plot it. So -1, 4 would be here. C is at 6, -3. B is at -2, 1. And D is at 5, 1. Connect them in a way that makes sense. So keeping in mind that we're making a polygon, so we don't want to cross through our shape. All right, so I can't draw a straight line on this program. So decide whether it's a trapezoid, where we're going to want to look at our characteristics. It has to do with parallel and non-parallel. Nothing about length. So when we're talking about parallel, we're talking about slope. Right? Parallel lines have the same slope. So just looking at this figure, if it is a trapezoid, then AD would be parallel to BC. So I want to find the slope of those lines. So remember, slope is y2 minus y1 over x2 minus x1. So I'm going to plug points in. So I have x1, y1, and x2, y2 for my AD. So 4 minus 1 over negative 1 minus 5 is 3 over negative 6, which reduces to negative 1/2. So that's AD. BC, my point here is at negative 2, 1, and then I have another point down here at 6, negative 3. So again, xy, xy, make sure you get them put in the right spot. So I have 1 minus negative 3 over negative 2 minus 6, or you could flip both of those as long as that 1 and that 2 are vertically aligned. So 1 plus 3 is 4, and 2 minus 6, negative 2 minus 6 is negative 8, which reduces to negative 1/2. Now, just to verify, you can kind of tell by looking, but it's good to prove everything. These are parallel. So right now I have one pair of parallel lines. I need to make sure that AB and DC are not parallel. So I will do those slopes really quick. Go ahead and pause the video and try that yourself. Just to get that practice. Okay, I did these a different way. I have them already graphed, so I just counted my rise over my run. That is perfectly fine to do as well. Make sure you put the rise on top and the run on bottom. Okay, and make sure you take into account if it's negative. This slope is going down, so it should be a negative slope. So those are parallel. These are not. And so, yes, this is a trapezoid. A, B, C, D is a trapezoid because there's one pair of parallel sides and one pair that's not, which is exactly what you should have. All right, so subcategory of a trapezoid is an isosceles trapezoid. So going over here, trapezoids have exactly one pair of parallel, I don't know why I did a hashtag, of parallel sides. And one pair that's not, if you want to keep getting specific with that. But underneath trapezoid, we can also specify isosceles trapezoid. And keyword here, isosceles, the same things that make an isosceles triangle an isosceles triangle make an isosceles trapezoid an isosceles trapezoid. Let's find where I've got too many things open here. Here we go. So it is still a trapezoid. It has congruent legs. A trapezoid with, I don't know what I just did there. Congruent legs. Remember, the legs are the non-parallel side. And, oh, never mind, we're going to talk about that down here. So, when you see an isosceles trapezoid, this one and this one will be marked congruent. Okay. Other characteristics of an isosceles triangles, the base angles are also congruent. So that's why I was specifying earlier when we're talking about the bases. When I say base angles, I'm saying this angle here and this angle here are congruent. And then this angle and this angle would be congruent. So again, thinking about parallel lines, if this was a transversal, right, these are definitely not congruent angles. Those are consecutive interior. The diagonals in an isosceles triangle are congruent. Again, if you use a little bit of logic here, if this and this are the same, all right, then, and this is congruent to itself, and then these are parallel. And so you have alternate interior angles that are the same. So here and here are also the same. And then this triangle is congruent to this triangle by like angle, angle, side, essentially. And so you can see that those diagonals are congruent. You just work your way around it. There's a whole formal proof. Anyways, the diagonals are congruent. If ever proving that, make sure you're using the diagonals. So like if this is A, B, C, D, make sure you know that it's AC that is congruent to BD and that you get everything plugged in the right spot. Okay. All right. We're going to find the missing angle measures given 1. So if this is an isosceles trapezoid, right, then we know that base angles are the same. So if the measure of angle M will equal the measure of angle P, then the measure of angle P is also 65 degrees. Right? Given these are parallel, the relationship between N and M so M and N are consecutive interior angles, meaning they are supplementary. Right, so 180 minus 65 is equal to 115, which means that the measure of angle N, which is equal to the measure of angle O, are both 115 degrees. Okay, so there's only 2 angle measures in this shape, just like with our parallel lines and transversals. There were only 2 different angle measures. Okay, mid-segment of a trapezoid. Mid meaning middle, segment meaning line. So middle line of a trapezoid is a line, segment, so is a segment. That connects the midpoints of the legs. So remember, a midpoint is halfway between 2 points. So the mid-segment is a point that connects the midpoint of AC, so if this cuts this in half, with the midpoint of BD, so if this cuts this in half. Now this works in every trapezoid, that's why I didn't mark these the same. This looks like an isosceles, but we're not going to make that assumption. So if this was isosceles, these two would be the same here also. Okay, so then they would all four be the same length. So let's give these some labels. Let's call this EF. So if it's given that E is the midpoint of AC, and it's given that F is the midpoint of BD, then we can conclude that EF is the midsegment of A, B, C, D. Okay, so just a reminder here, remember your midpoint is found by finding the middle of 2 points. So our midpoint formula was x1 plus x2 divided by 2. We found the middle of those lengths. Y1 plus y2 divided by 2. So this was midpoint. I'm going too fast for my thing. So a mid-segment is going to be, the length of it is the average of the bases. So it's halfway between both bases. It's going to be the average length of those bases. So the formula is base 1 plus base 2 divided by 2 gives you the midsegment. For this particular example up here, the length of EF would equal AB plus CD divided by 2, right? And you should be able to work this any direction. If I give you EF, you should be able to then find CD, for example. Okay. All right, so finding the indicated value, if I want to find HK, I'm going to just use that formula there. So again, DE plus GF divided by 2 is HK. So just plug in those values. 6 plus 18 divided by 2. 6 plus 18 is 24. Divided by 2 is 12. So the length of HK is 12. That doesn't get a line above it. All right. And again, being able to work either direction. So to find x here, we're using our bases because it's a midsegment, but this is the midsegment. And so when I add my bases together, it doesn't matter which one's base 1 and base 2. And divide it by 2, I should get 12. Right? So in order to solve for this, I'm going to multiply by 2. So I get 9 plus x is 24. And then subtract 9. So x equals 15. Okay. Remember that a midsegment cuts these sides in half. So for y, there's no solving. You just have to recognize the fact that KP is equal to PL. And so 3 is equal to y. Okay. So you don't always have to solve it, but you do need to use your properties to recognize what are equivalent. Okay. The last shape, or the last quadrilateral that we're going to do is a kite. Okay, so a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. This is not a rhombus. There's a difference. And you can pause the video and get that jotted down if you need. Another way to think of it is that it's two not congruent isosceles triangles, essentially. Okay, so like I have an isosceles triangle here, and I have one here. Okay, so like this is congruent to this. This one is congruent to this. But opposite sides are not congruent to each other. Okay, and that line's not really there. That's a diagonal. Okay. Yeah, so essentially you have two isosceles triangles. The cool thing about that is it helps us with our properties of a kite, our characteristics of a kite. Because they are isosceles, you have those congruent sides, but also like this angle here and this angle here are congruent because those are isosceles, which means that this angle and this angle are congruent. Well, then broad scale, this angle over here, so let's call this like A and B. A and B would be congruent. Okay, so things like that. So characteristics of a kite, the diagonals are perpendicular. From each other. So if I draw this other diagonal, these form right angles. Okay, so redrawing this here, maybe. Okay. So yeah, so the diagonals are perpendicular, but also the long diagonal bisects its angles. So this longer diagonal here bisects this angle, so that and that are equal, and that are equal, which you could prove by looking at the fact that these two triangles are congruent by angle side, because these are the same. And so that would prove that those are congruent. So long diagonal bisects its angles. Exactly one pair of opposite angles are congruent. Okay, so this angle here and this angle aren't congruent, which you can most of the time clearly see. But the ones by the short diagonal are congruent. So these here in between the two triangles are congruent. So these are bisected, these are congruent. All of them together add to 360, so lots we can do in there. And then we add in the fact that we have right triangles if we have the diagonals as well. Okay. So using those properties to find missing angle measures. So again, knowing that M and K are congruent or equal. So the measure of angle K is 88 degrees. All four of these add to 360 because it is a quad. All right, so if we have 88 plus 88 plus 120 plus, we'll call it J because it's angle J, all should add to 360 degrees. So combining those like angles, we have 188 plus j equals 360. So j would been the measure of angle j would be 360 minus 188, which is 172. All right, so you can find all of those angles given just two of them. So even if we're not given the ones that are the same, we can work together to find these because we know m and k are equal. So let's just call that x. All right, so if I take 60 plus 50 plus 2x, I'm going to get 360 degrees. So again, quadrilateral always will add to 360. And then I can solve for my x. So combining like terms and subtracting 110. And then dividing by 2. Okay, so each of those angles, angle M and angle K, are 125 degrees. Other problems that we will have to solve with kites may have to do with your right triangles and finding different lengths using that. Let me back up one step here. The long diagonal also bisects the small diagonal. Okay, so this and this are the same. And so, again, because of all those equalities and knowing that they're right triangles, there's a lot we can do in those problems. So, I know those notes were a little long. Hopefully you're okay on all those properties. Go ahead and finish filling in your flowchart. So add those properties of kites in there. And have a good night.